In this video, I'll be doing the maths question you see on the screen here from paper 2 of the 2024 Maths Leaving Cert exam. If you're looking for a different question from this paper, check out the playlist in the comments below. I'll be doing all this on a whiteboard, hopefully like you're used to your teacher doing. But remember, you're not in a classroom here, we're on YouTube, so take advantage of that. Pause, rewind, watch a half speed or watch a 2x speed. If you do find these videos useful, or any of my videos, I would greatly appreciate a like or subscribe, but especially I'd appreciate you sharing it with a friend doing the Leaving Cert or doing it next year. Question 1 is multiple statistics question, all revolving around swimming times of students. Now there's a couple of controversial ones in this. A part 1 I think is slightly wrong, and part C again I think is slightly wrong. I'll talk about them as we get to it. Well, we'll start with A part 1. They give us this data set up as a stem and leaf graph, and they ask us, they tell us the mode is 34. So mode is 34. Use this information to find out the value of A here. Now I just think that's slightly wrong, because a set of data can have multiple modes. Now they don't, I guess if they said A mode was 34, well then A would have multiple answers. But I guess they do say the mode is 34, but that seems more like an English question. So they're saying there's only one mode by using the word the, which again I think is bad for a maths question. But anyway, what they're saying here is there's one mode, and mode is the number that appears the most often. So remember how to read this. This is 20 some number, 22, 27, 30 some number, 34, 34, 35, 38, and so on down. And there's only one number that appears twice, is two numbers that appear twice. 57 appears twice and 34 appears twice. So to be the mode, the only mode, A would have to be 4. So that's the answer in this one. A is equal to 4. Okay, for part 2, the range of the data is 49. Use that bit of information to find B and C. Here's B and C. Now the range of the data is the distance between the last number, 60 something, and the first number, 20 something. But they only give us one thing to find that two numbers, so that's not quite enough there. But we actually already are able to find C without this number here. Because remember, when you do a stem and leaf properly, everything's in order. So all these numbers are in order. So there's only one number C could be. It has to be more than 68. And 70 would be on the next row. So C has to be 9 to make this number 69. So C has to be 9. We can say that straight away. And then using this range information, we can say 69, this last number here, minus 49 must equal this first number. So that equals 20. So that first number, B, must be the 0 from here. So that's how we answer part A part 2. Okay, A part 3. The median for this data is 43.5. Use that to figure out what D is. So remember what the median is. It's just the middle number, or sometimes the middle two numbers, and we get the average, which it will be in this case because 0.5. So what's the middle number? Well, I just like to take 3 off. I just like to tear away both sides. There's 5 in this row, there's 5 in that row. Get them all gone. So the middle number of all of this is actually the middle number of this row. So then I like to just start covering up, and we're left with D and 5. So you can think of this as 40 something and 45. Well, let me do it that way first. So 40 something, we don't know. Let's just call it X. Plus 45. That's these two middle numbers. So we don't know this one. We do know it's 40 something. X and this one 45. Divide that by 2, and that does equal 43.5. That'd be one way I'd do it. Sorry, that'd be the most maths way to do it. And we just go ahead and solve this. Multiply both sides by 2. We get 87 over here. Take 45 from both sides. We get X is equal to, what is that, 42. So really we're saying D is equal to 2. And that is the answer. Another way would just be to start guessing some numbers. D could either be 2, 3 or 4. That's it. But we know it has to get an average out with the 5 here to get 3.5. So it couldn't be 4, the average would be 4.5. It couldn't be 3, the average would be 4. 2 is the only one left, and 2, the average would be 3.5. So you don't have to do the maths, but it does help. So there's your answers. A is 4, B is 2, B was 0, C was 9, and D was 2. In part B, we sort of continue on with the information. Of those 22 students in the first part, 7 of them did swimming lessons. And here we wrote down the times they did in the first part. So 22 all the way down to 61 here. Or sorry, not times, that was the distance they were able to swim without stopping. But after they took swimming lessons, those same students got these distances here. And that was a graph. They've done it there properly for us. I've just roughly thrown it up here. Some sort of graph that looks like this. And they ask us the question, how would you best describe how the results have changed for these students from the initial test to the retest? So they're just looking for a bit of English. Describe what you see. Say what you see, as it were. They're looking for 2 important things. They want you to notice that everyone improved. Even if everyone didn't improve, they would probably want you to notice that most of them improved. In this case, though, everyone did improve. But then the second thing they would like you to notice is the bad swimmers improved a little. The good swimmers, the ones who were already good, they improved a lot. And the same, the middle swimmers improved a fair amount as well. And that's where this sort of graph tells us. It's not a linear looking graph. If this is getting a bit complicated, you don't need all, that's enough to get full marks. But really, if you found data that looked like this, and the slope here would be important, slope equals 1, this would tell you everyone was the same. Before or after the test, nothing changed. If you had a slope less than 1, it would mean people got worse, 0.8, and a slope bigger than 1, people got better, 1.2, something like that. What's interesting here is it's not a straight line, so it's not linear, but we could still get the derivative or find the slope at a tangent. And actually the slope here is already bigger than 1, so this is, bigger than 1. Well, here it's even bigger again. Let's just say bigger than 1, and here it's even bigger again, bigger than 1. You don't need any of that extra. Just basically they all improved, and their improvement got more and more as they went up. Okay, that leads us on to part C, which I have a problem with part C. Part C, they say the coach worked out OR. OR is the correlation coefficient in this data. So you remember that. That's data that looks like random should have a coefficient of 0. Data that is correlated, linear data that is correlated, should have a correlation of 1. Or if it's negative, if inversely correlated, just going down basically, it should have a correlation of less than 1. That's fine when you're dealing with lines and straight lines, linear functions, and that's all the Leaving Cert really teaches us. So if you were so you can put all this data into your calculator, and you're taught to do that in the linear mode, or a line basically, and you will get the answer. Let me just check here. You will get the answer. This is correct at 4 decimal places, 9145. And that's the answer that's in the marking scheme's just out in the last day or two. That's the answer that's in the marking scheme. But honestly, I think that's wrong, because this clearly isn't a straight line. This is maybe it's a polynomial, which you get a certain answer, or maybe it's an exponential. We don't actually know. And your calculator can do those. So like personally, I think it looks like an exponential, and my calculator tells me the answer then is 0.9920, correct to 1 decimal place. But anyway, this is the answer they gave you. We don't teach this far into the Leaving Cert. I just think it was a bad question. But if any of you, probably top students, are wondering, wait a minute, that's different. I think it's wrong. But then again, I'm not an expert in statistics, so I could very well be wrong on that one. I just think there was some slight issues. Also, remember, how do you do this? You can do it by hand. It would take you 10 minutes and a page of writing. But calculator, learn how to use your calculator. My calculator is different. I don't plan to do tutorials on calculators, I'm afraid. You'll find them on the internet though. Find someone that does them, and it's very simple. You just put this data into your calculator and then ask your calculator to give you loads of facts about it. One of the facts they give you is ore, and that's one of these numbers. Okay, that's it for question 1, which I thought had a couple of controversial issues in it. If you disagree or agree, let me know in the comments. Thank you for watching. Have a good day.